Failed deployment. These are the cause. We have already discussed insufficient quota. Now we will discuss limit and ranges, and rest of will discuss later. So stay with us. Episode 26, we can apply in deployment. So our topic is resource request and limit in Kubernetes for today. So let's get started. Today's topic is request and limits. MITS, limits. What are request and limit? Request. The words itself says how much you want. Could you please give me a glass of water? Hence, one glass of water is your request. But limit. It's don't cross your limit. Varna thappad padega. Don't cross your limit. Means if you cross your limit, what will mean, whatever the consequence, you are responsible for that only. Okay. In terms of Kubernetes, it's in memory and CPU. So 1 means you can say 1000 M, and memory is represented in MI and GI. Okay, so request means minimum amount of resource it guarantees. Minimum amount of resource, and this is very important, guaranteed. And limit, these are both are plurals, so keep it in mind. It's a maximum won't be tolerated amount of resources it can use. So generally this is the main thing. We'll dig into detail. So let's say a node capacity CPU is 1, or you can say 1000 M, and memory is 2 GI. Okay, suppose pod A request 500 M and 500 MI, pod B request 500 M and 500 MI. It's 512 SA, so it could be bested, right? So pod C, just forget everything that overhead or whatever, just for understanding purpose. If I request 100 M only here, but this is 500, this is 100, it already occupied all things, so this pod will goes in pending state, not because of memory but because of CPU. Scheduler only look for request, so scheduler only request look for the request. Okay, so this request fulfill, this request fulfill, but this request is pending because nothing left for C. Okay, means if you have 4 bread, if you have 8 bread, 4 is occupied by mummy, 4 is occupied by papa, then nothing is left for you. It's like that one. So now you have to adjust this request. So you will adjust it like 300 or 100. Now it's 700. It will be this pending state pod will come or may need a restart. So if CPU exceed limit, what happen? In memory it's different, in CPU is different. If for memory, suppose request is 100 M, sorry, for CPU I'll say request is 1 GI and limit is request is 1 GI and limit is 1.5 GI. If this goes, if beyond this, so you can say it's a throttling effect, means slow and unexpected behavior. If memory, like say it's a 100 memory and it's 150 is limits. If it is goes beyond that, then container killed, and you will see OOM. Sometimes you see this OOM is known as out of memory. Another thing came into the picture, overhead. For CPU, it's approximately 5 to 15%. It can vary from company to company, but in generalized way, for memory, it's 15% to 20%. We can keep both 10% also, 15% also. If it is not mentioned, it's your call how much overhead you have to take for work to done. Now one more question is that there are if there is a deployment, and in deployment there is a main container and init container. So request, if you define equal request for both equal, then it's okay because it will not add up. In container will do something and then main container will work. But for a sidecar container, means there are 2 container or multi-container, both resource will add. Suppose here only if you defined here, then at last 100 M is utilized, which means it's a request fulfilled. But here if in multi-container, container 1, container 2, container 3, all will be add up, means here 100 M, here 100 M, here 100 M, then all will add up and here 300M will be the requirement. Init container run one by one. Before the main container is start, during init phase, only init container resource are utilized. Once init finishes, then this main container resources. So means for init container means both, whichever is higher, scheduler consider that. Okay. For main container, this all add up. For CPU and this all add up. So keep it in mind for init container and multi-container scenarios will be different. Most people get confused in the request. It's a minimum guaranteed and when it matters and what it does. Minimum guaranteed and its requirement during scheduling and limits its maximum uses allowed, and it's a during runtime execution. It's a static reservation. Scheduler uses a user request to decide which node has enough free uses CPU or memory to run the pod. It's guaranteed. Okay. And this limit container can't go beyond the limit. This is enforced by C group. This is maximum container can use. Means if node has 2 GI available, but still for pod you can define GI 3 GI because it matters for the runtime after execution. Means maximum that because this is maximum, it can go to 2 GI for the sake of understanding. But if the request is 3 GI, then pod will be in pending state. First of all, we want to know how many container run inside pod deployment. Okay. So there are two type of container. Means first it's a init container or you can say multi-container. Both are multi-container, but some may have init container or some run parallelly. Okay. So let's have an example for both. I have a file. This is one is running. But if you will see inside my YAML file, here you find init container and container. Okay. I'm creating one more file which has two container, but this time no init. It's a sidecar pod. You will see here you'll find 2 out of 2. Here 1 out of 1. This means init container has done his work and now main container is running. Here there are 2 containers and both are running. So we need to know how much container is there so that we can allot memory and CPU. We can request memory and CPU for them. So first of all, get that deployment into the YAML file, because here we are created that deployment, so that YAML file is available with us already. But in many cases, you won't have a deployment file ready with you. So K or kubectl get deployment, or you can say pod or any resources, and here namespace here is default, but there might be that YAML file that deployment is in a namespace YAML and then redirected to, I can say, neokloud.yaml. After you have this deployment file, this backup, so you can cat neokloud.yaml and with a very beautiful command grep -i, you can write container. Why I write I? Because it will show the lines with container, side container, r or partial where it is word is there. Then I can use the same command, but I can have E here, -ie, and I can write container or image. So I can double verify it, how many containers are there. Because in case, so let's get to work. This is extended expression, regular expression. So I will just, I'll make it now kget deployment tabs. Here multi app and this kget pod. Here 2 deployments is there. I'll control L, kget deployments and kget pod. So I will take this YAML. Okay. I want to know in this YAML how many containers and this YAML how many containers. Both the processes same. I'll kget deployment multi app -o YAML neo YAML cat neocloud YAML grep -i container. You'll see I'll write it in here. You'll see one container is showing because other is sidecar. Other container is sidecar. If multi app my app, if I'll do same for my app, get deployment my app -o YAML Neokloud.yaml. Sorry, I said I have means done mistakenly. -o YAML multi app YAML Neokloud multi app.yaml, and it is my app.yaml. Now we have two files. Now we'll already seen this. We have find this only single container. Now with the same command here you will find two containers. So but then in init container you are able to find this type of thing with the help of this command, but not for multi means sidecar type of thing. So now I'll write here image, and here I will find I'll write So in my app you will find two container with image, and if I'll do this for multi app, then also you will find two images. So you can have two containers, means this two images showing that two containers. Okay, so in both case there are two containers, but in this case the resource will add, in this case resources will not add, request will not add, sorry, request will not add, in this case request will add. So now there is control plane and node 01. Pod and deployment will deploy here tent is there, so no pod or deployment can be deployed here. So okay, so we have to worry for resources of these nodes, for these nodes. So or in broad lines, there in broader area there would be namespaces where resource quotas is allowed or created for that thing, so we have to utilize for that, but that is different means that is very little bit advanced topic. So we are we'll look here, that advanced topic we'll cover later. Now I will type k get node, k describe node 01 node 0. So here you will find I will little bit reduce the font size. Here you will find many things. Our is capacity allocatable. I'll copy this. Actually creation of tutorial will take much time, and so I will upload that image. I'll clear this. Okay, now let's understand this thing in little. So you won't find any difficulties. This one is 1000 amp. Okay, here you will see this is the capacity. Okay, total capacity. Here is allocatable, means after that things it's allocatable, and now you will see CPU request, means this many is already utilized, this is already utilized. If you see the summary allocatable resources, means this is already 85% is already utilized, and this is already utilized. It's a limit, means maximum how much can utilize, 100% can utilized. Okay, and now if you calculate it, CPU request, it is, you can say, you can find out it's a 850 m. Okay, means only one minus 850 m, so only 150 amp, means only one this can be entertained. Request of 150 amp can be entertained. If you request more than this, more than 150, that pod will go to the pending state. Okay, so now I will create a pod with the request of 200 amp, and let's check that pod will work or not. Well, look, it is in pending state. Okay, delete. Now I will edit this, and I will define 150. I'll remove this memory tags. We'll see it's running, because, and if you will describe node again, you will find 100% utilized. Okay, request is 100% utilized. This allocatable resource is, now you won't able to run any resource. So thank you so much for your love and support. Part 3 will create soon. Hope you will understand this concept well. Thank you so much for your love and support once again. Stay connected, stay tuned. Some videos we are not able to upload due to some policy issues, and but I assure you, means if you watch CK important video in my playlist, you will able to solve 100% of the exam problems. Thank you so much. Here is a part 3rd of request and limit. These cartoon sketches were drawn by me earlier using tablet, just to show an example. She is Mama, she is Tina, Meena. I will take a small Meena and Dika. Tina, Meena, Dika. Okay. So Mama has 1,000 rupees. Tina takes 500 rupees. Meena takes 500 rupees. And Dika, nothing is left for Dika. So Dika is crying. Dika is crying. This type of situation is happen with Kubernetes also. When first pod gets pods get request fulfilled, and nothing is left for another pod, and there's nothing is left for the pod, some pods, and those pod will go into pending. So we have to take request little seriously. So what happened now? Papa comes into picture. Papa thought, if mama gives everything to girls, then what would be if there is an emergency? Mama should take at least 10% of money, and in technical language it can you can say is overhead. And now 10% means 100 rupees, means now mama left 900 rupees for these three girls. Mama gives 300. Now 10% overhead means 100 rupees. Now mama left 900 for girls. So to share equal amongst all girls, 300, 300, 300 will be given to all girls. Okay. Now every girl is happy. Dika is happy, Mina is happy, and Tina is also very happy. So now all went to the dinner. If all went to the dinner with one friend, then whatever the money have will be divided by 2. Means 150 expense will be of that friend, and 150 of that Tina. Like 150 for Mina, 150 for her friend. And here with Dika also same situation. 150 for Dika, 150 for her friend. This is the scenario where parallel means this is the scenario of multi-container. If two containers is there. Now with init container, what happened? Means like it's a race. Set some complete half the race and then take and complete the race or running. So the request elements 300 will be fine for her friend. Now 300 is here, means whatever the maximum, if it is 400, then resource would be the maximum 400 required. So because init container work is completed here, no more resource required for init container. Now resource required for this container. Okay, if earlier it is required 400, so whatever the maximum resource required will be considered for the schedule. So I will create the pod accordingly so that you can have more clarity. So I will open a clear coda platform. Okay, get nodes. You'll find 2 nodes. I'll deploy a scenario with means what I had discussed, 500 to Tina, 500 to Mina, and nothing left for Dika. So here I will create a deployment with you will find the YAML file here in my buy me coffee page with the CKA init container. I will copy this and create a YAML file. Now here I will make resources like request would be 500. I will check how much resources available. Okay, drive node 01. Here in allocatable only 125 is utilized, so still left with 875. Okay, means year 1 is 1000, so 875. So what you will do, echo $1000 minus 125. Space is very important. Sorry, one this is 875. Now 875 is there. You have to so I will divide it by 3. So let's say 400 I will assign to Tina, 400 to Mina, and 125 to 75 to Dika will automatically get, because that is only left with so I will make changes here. So I will make CPU 500 400 and limit I will make 500. And one more thing, replica I need to set to 3. I set to 3. Here init container is also need to change accordingly. This we have changed in init container. This is init container. Now we have to change in init container also. 500. CPU is 400. Here I'm not worrying for memory, but you should practice with the memory and CPU both. Let's check the result, what happened. But look, these 2 pods is running and this third one is not ready. It is pending. If you check describe pod my app mx insufficient CPU. Okay, now I have to make it work. So what I will do, I'll just check k get k describe node 01. So here you will see 925. Okay, means it is request is 925. So you have to 925. So my idea is here that this I will make it little lower, means little font. Here you will see this is 125, means 1000 minus 125, 875. So you need to manage 3 pod in 875. Okay, and let's do calculation. So here I'll make this now this fifth this 25 25 50 25 plus 25, this 25 50 50, you will say it's 125. Here allocatable memory, you will see 1 CPU is 1, means 1000 will take 10% overhead, so it is 900. This is already occupied. Sorry, we have to check node 1, node 01. So it's 900 you have to manage, but in 900 125 is already utilized. So what you left with is 775. Approximately you will take you'll take it 750. Okay, so it is divisible by 3, and we will get 250. Okay, and how do you calculate this in Linux? So we'll do echo dollar this 2 sign, this 2. Now 1000, 10% is 100 minus 100. Now minus this is 25 50 50. 25 minus 50. Space is very much required, otherwise you will not get any answer. 50, close the bracket, you'll get 775. I consider it at 700. Okay, so 775 divided by 3, so it come to 258. So I will consider that 250. So what could be the steps? I need to scale it to 0. I had to scale it to 0, and this is means okay, I have done my calculation that 250 is required for each pod, but now get my apps, and I will take this in YAML file. Sorry, video is little slow because cloud.yaml. Okay, now I already said you this command neocloud grep, and then -i image, or you can say container and image. I'll type E here, capital E. So you can find many here image. So you find there are init container, and so you don't need to divide it. Okay, equal you can use. So now you can edit, or you can change this YAML file and apply. I will edit it. Okay, so first scale it. So I will simply write a command k scale deployments, and deployment name is my app, and hyphen replicas equal to 0. Now I will edit edit deployment my apps. Now here you will have to take care of. You need to just find resources. You can slash limits. It will directly go to the limit, and there you can go to the CPU section. You have to change the request only. I search limits so that we can go there. You can type slash requests also, but it is longer word. So now press I, and I will make it 250. Now for more, now here 250 is there. Now we have to change in request also. Here also 250 and WQ. Sorry, before editing you must save this YAML file, because something goes wrong, then you can always have that file in backup. In exam, I always appreciate if you would say save backup. Now again scale replicas to 3. Now k get deployment. Now k get pod. You'll find this all is running. So it is a little tricky, means there are stepwise. If you go stepwise, then you will always be succeed. Don't be in a hurry. As always, first of always save backup, then scale, then edit, then do the things. Thank you so much for your love and support. Once again, we are back with another question, and this is a mock question about request and limit. This is a part 1, and part 2 and part 3 will be coming soon. And let's get started. Create a deployment name memory demo in the default namespace with the following specification. It must run 4 replicas and it must have a single container using image and Nginx Alpine, means there is only single container is running in the deployment, and fair memory and CPU request to set. Limit request is exactly double the request, and the pod must run successfully without hitting memory scheduling constant. So if you are not aware of request and limit, so one beautiful video is created in the playlist. You can watch it so you can have a fair idea of request and limit. So let's get started about a very simple hint. Request to fulfill, limits you don't cross. Okay, so I'll get node 0 nodes. So here are 2 nodes. If you do 2 nodes, but here control plane node tent is there, so you cannot schedule a pod in control plane node. Here particular in clear coda. Somewhere else if tent is not there you can, but here tent is there. So I'll describe describe node 01. So this is already utilized thing, means 125 is utilized and 100 mi is utilized. Just go up. This is the allocatable, means from this is you can allocate, and already what allocated is this. Come, it is a little slow so it is lagging, but this is 125 is already allocated. Where it is allocated? For this. Okay, so what we left with is this is already utilized, and one is our, so this is KI. So I will convert it, just a simple, means you don't need to much. Paste 1024. Sorry, I forgot. 191.22960 divided by 1024. Okay, so you just type ACHO $. I'll copy this allocatable thing, this allocatable. This is KI. I will convert it to MI. So space should be there, and divided by 1024. So this is the MI. Okay, and 1000. Sorry, this is 1 equal to 1 CPU equal to 1000 M. Great. So in this 1000, this 125 it utilized. So you were left with 1000 minus 125. So 875. And you have to divide into 4 pods. Okay. So basically if you divide it by 4, then nothing is left for any other thing. So you have to take some overhead also. It is advisable. So 10% if overhead is kept, so into 10 divided by 100. So 87 is overhead. So we'll take round figure, that 100 is an overhead. Okay, so 775 we take. So 775 you have to divide it in 775. You have to divide in 4. This is the CPU calculation we are doing. So it is left with 193. We'll take it 180. Okay, or 190. We can say it is 190. And this memory part 1868. So this minus means 1768 is left, and 1768 10% you overhead is you can consider it. So 1768. So 176 200 you can minus it. So it is left with 1768 minus 200 means here 1568 minus divided by 4, 392. I'll keep it 390. Means if I take 198 means 390. So basically our request is 190 and 390. This is 190. CPU is 190 and requested memory is 390 mi. This will set. If it is not given, then you can assume it like this. So now I have to create 4 replicas, so need to create a deployment. Best just go to the page, type deployment. So deployment file is there, just template and copy. So via depl.yml. So paste it. Here name should be there. Name, what name is? Memory demo. Replicas set to 4. Label don't means not mentioned. You can choose your own. So selector match label is nginx, app equal to nginx. Now we have to put template. In template we have to so you find that below metadata, this is the spec section of the container. Okay, so just here request and limit search, and here you will find that request and limit, and you here one file is there. So just from a spec section, copy this spec section, copy and paste it here. Paste. Need to adjust because resources, then request, then memory, then CPU, then limits, then memory, then CPU, and the name. And this is the two pod. So this is not required. Multi container, but this is not required, so I'm deleting it. So I assume this file is okay, so I'll wq it. Sorry, this need to change because our is 190. This is what we have set. It is 360, I think so. I'll wq it and just go up and down. So here request is 190 and this is 390. Okay, means 190 multiplied by 2 because you have to double it for limit. Echo, just note down this command because most of the time some different command you will run in examination and that won't work. So and this is 390, so this is limit 380 and 780. Okay, so now edit. I'll edit in another file. Okay, another tab. Okay, via deployment YAML. So tab 190 390. So you need to create 190 390, and then here it's 190 90, here 380, and here this 780. So wq. Now k apply happen depl. So k get pods, get deployments. 4 out of 4 is ready. K get pods. Error pullback image. Okay, so we'll change its image. We'll check which image. K delete deployment tabs. So instead of this image, I will take my image because image nginx helpline is given, so I have not taken this into account. So make wq and k apply and not press YAML file or what. This is memory demo. So control L, k get deployment, nothing is found via dpl. So I'll copy it to via dpl. I'll copy it to dpl YAML. Okay, now I'll apply cat dpl YAML. So this is the file. Actually I mistakenly used via ym, so you should not use that YAML file. So I'll remove that file. So k get, now apply k apply -f deploy YAML. So k get deployment, 4 out of 4 is deployed, and k get pods, so 4 out of 4 pods is running. So your condition is successful. Now k describe deployment. So you'll find this CPU memory is here. Okay, now control L, k get nodes 01, describe. So you will find our 4 pods, which are, this is the requests and this is the CPU limits, and this is the, I'll make it bigger so you'll find the whole picture. This is the memory request. So keep it in mind that this could be anything, but this is what requested at the time of scheduling. And instead of, you can take it, if this is something big or something not achievable, then your pod will not work. Okay, like now only I think 115 left. So if I create a pod, or I make replicas to 6. K scale replicas, K scale deployment, my replicas to 6, only 5. So you'll find one pod get into the pending state. Now we'll see. This is not the part of question. This we are doing extra. So K get pods. So this got in the pending state. Okay. Now if I asked you, means make it running. So calculation is the simple. This should this whole pod memory should be divided into, means you add up this 1 2 3 4. Okay, or whatever, means excluding this memory, whatever memory is left you divide by 4. Suppose here we'll get 190 190 190 190. So 190 into 4, so echo 190 into 4, so 760. Okay, 760 you have to divide it into 5. So I'll divide it into 5. 760 divided by 5, so it's 152. I'll take it 150. Okay, and similar with the memory, 780 divided by 4, so 780 into 4, sorry, 390 into 4. Request we will consider 390 into 4 and 1560 divided by 5, so it is 312. I'll take 300 round figure or 310. Okay, then 150 and 310. So what I will do, via edit deployment YAML, edit kedit deployment, always save backup deployment my request demo. So here go to the just file colon / limits limits and press N, and you will go to the limit section. Now you have to change it to 150. Sorry, this request to change to 150, and what we have seen there, I forgot, here 150, then it will be double that 300. If you ask, if I'll make, means if I'll leave it as it is, means 380, then also no worries. It depends what actually asked in question. So limit I can edit, I can change, I can leave it alone, because leave it same, because it doesn't affect, but in future performance it may affect, but at the time of scheduling it won't affect. So it's 380 and 380 divided by 760. I won't remember, I'll open in another tab. Okay, so 380 and 780 and tab 2, just I'll save because I forgot that number. So it's 150 and 310. So just limits and now I'll change only CPU, that is 150 and it is 310. Okay, so wq, so get pods. So what we have done, this is 150. In request we have changed it, file wq, save it, no changes is made. Okay, so better first we have to scale it to 0, means 0, because this is the deployment. So our strategy is rollout. So first scale it to 0, then edit it, and then make it 5. Now you will see that all pods are running. So thank you so much for your love and support. We'll come back again with new episode which could be little much interesting than this. Thank you so much once again for your love and support. A deployment name memory demo, the default name is space with following specification: 4 pods should be running but few pods is not running. Troubleshoot and fix the issue. A fair enough memory CPU request to set. Limit should be exactly double the request, and fair overhead should be there and can scale down deployment to 0. The pod must run successfully without hitting a memory scheduling constant. So if you are not familiar with this request and limit, one beautiful video is there in our playlist. I recommend you to watch, so that this concept is very clear to you. But just briefing about the things: memory, CPU. One CPU equal to 1000 M and 1024 Ki equal to 1 mi and 1024 mi equal to 1 gi. So we'll start. Uh, for any pod to run, it require memory and CPU. So what is a request? Means it's the minimum required to run the pod. If suppose request 100 m and suppose node 01 has 200 m available, so this pod will run. If I will run another pod with 100 m, then this pod will run. If will run another pod with 1 m, this pod will not run and goes to pending state. Okay, similar like the memory when request is set, but in limit request set to anything means you can limit set to this also. Limit set to means request limit can be over limited, over committed, but this should be within the requirement. If I'll go to the page and I'll describe node 01. Why node 01? Because control plane node has a tent, so it will not use for scheduling of things. So here you will find that 875, and so only 875 can be handled. And here you see that memory is this is the request can be entertained, but here one sentence is written limits may be over 100%, that is over committed. So it could be anything, but resources this should not be more than 100%. So a deployment memory so I'll deploy one a deployment memory demo is in the default namespace. So get deployment, you will find memory demo is running, and when we get pod, so you'll find that 3 is running but 1 is in pending state. So what I will do, I'll just describe node 01. So I'll go up, I'll make this little small so you can see. So in describe node you will get from here this status is there, so you will get rows label, it is not of our use, it is not of our use. Then we'll get to this, it is also not of our use. Here two things is mentioned. Okay, this is ephemeral containers and this our concern is of this. So this ki and this cpu, this memory and cpu is of our use. So I'll copy it, save it, and then this part is of our use. Okay, so I'll copy it from here, and this is of our use. So you are seeing here 3 pods is running. So 3 pod is scheduled and CPU is only this one. Okay, so I'm being a little here little slow so that you can understand the logic well. So here 1 means it's a 1000. 1 is 1000 m, and this memory is you have to convert it to mi. But no, it is converted to mi. So what is the CPU? This copy and echo dollar this and here v space divide symbol, then 1024. So it is 1868. So it's 1868 mi. I'm writing only this part because this is the unit. Okay, now here is 250 250 250 is 750 and memory is 1500. Okay, and this is 875 means this is already occupied because this include this also. So what we left with is 125 m. Okay, so at the time of you should take this, and I want 10% overhead also. So this, so what this include? Overhead should be 10%, 15%, 20%, according to the means it varies. Generally I will take it as 10%. Then this one 25 m cube system 25, 50 and 250. Sorry, 25, 50 and 50. And then this 7 pods. This is 250, 250, 250, and one is not, it's in pending. Okay, so let it be, means we'll take the means it is pending. Now this will not consider because we have to edit it, have to adjust these two things, we have to adjust. So from this 10%, so echo dollar means you can do my calculation. I will do calculation in that terminal. We simply take the logic overhead equal to 1868. I'll come to the next page because here a little space is left. So 1168 and this is 875. So only 125 is, it is of no use because it shows total capacity or request there. So 1168 memory 1868 mi and CPU 1000 overhead 10%. So it's a, we'll calculate it, it's 100, and then cube system it's a 125. So it's left with 775. Okay, now CPU and it's a memory is 1868. So 10% 186, I'll consider as 190. Okay, so and cube system is 100 mi, so we'll minus 100 also. So 1868 minus 190 minus 100 equal to 1578. I'll take round figure, means this is 1578. 4 pod to be run. So I'll take it 700 and I'll take it 1005. I will divide it by 4. Divide it by 4. So clear, 1500 divided by 4 equal to 375. I'll take memory as 375 and 700 divided by 4. I'll this take it 175. This is about the request, and then limit. It is said that it should be double. So 175 into 2, 350, and 375 into 2, 750. This you have to edit. So let's check if this is it, then our pod will work or not. So just I'll make it little okay. So let's get to work. Now I'll calculate for CPU. So echo dollar, I'll make control L. Okay, for CPU 1000. Okay, overhead is echo dollar 1000. Okay, it's an integer. So 100. 10 divided by 100. Why this is giving error? Let me check. Error token is go cross 0 1 10%. Oh, sorry, this 100. This is 100, and now well overhead is 100, and now that echo cube utilize that cube system utilization is echo dollar. It's for integer calculation, so don't add float in this. 100 is 25 plus 50, and space is there 50 plus 50. Oh no, 125. So echo dollar 1000 minus 100 minus 125. Oh shit, I have to correct again. Oh no, this is, so we left with 775. So I'll control L that available 775. So echo, I'll take it is 700 for the safer side, or you can take this 775 also, but I'll make it 700 so that 4 pod. Sorry, I'm doing typo mistake every time because I'm watching in second screen and my keyboard is in first screen. 775 is a 175. So memory we have to assign 175. And similarly, you can do calculation for the memory and you will get it is 375. So I will edit it and check whether the things are working or not. First, get deployment apps and my memory demo, and I need to take a backup. YAML backup L hyphen question number 7 dot YAML. Sorry for a little sound issue. Now we'll edit. We have taken the backup of deployment apps. So now I'm editing these values. K via vi k deployment memory demo. So if you will scroll, if I scroll down, there is init container also. Oh, this is a good, this is going to be tough now. Don't worry, we'll escape it now. If init container is there, you know, you can define same for both, for main container and init container, you can define same. For scheduling, whatever be the greater, that taken into account, because this init is always says that in it. So there is no extra means required. If this init is 400, then scheduler take this 400 into account. Okay. And main container is 300, no worries. Okay. If init is 300, init container take 300 and main container take 400, then this taken in it when account, taken into account for scheduling. So whatever the max it will take, and but we are keeping it same, then no worries. For another container, for something, if side container are there or two container are there which is parallelly running, then you have to divide this by number of containers. Suppose it's a 2 container, then divide by 2. If it is a 3 container, then divided by 3. If it is a 4 container, then divided by 4. So it is a init container. We not worry for this both of the thing, request and sorry, both memory and this you can divide it by. You no need to divide it by the number of container. But if it's the case of sidecar container or parallel container, means those container are running in parallel with the main container, then you will need to divide that request to equal or means something like that, means so that this whole can be consumed by 2. Otherwise you will left no resources, because there will, this is mean there is a 175 and this take 175 main, this take 175 side, this take 175 main, this 175. So you need more resources. Okay, so now so no worries for this init container, there is no issue, we can edit. And file is very big, so request search request, and there you can edit. It's a 175 and it's a 375. If it is asked 375, then it's a 750. Limit is not mentioned, but if limit is not mentioned, but in question it's given. So if it is in question, it is not asked, then don't worry. But it is asked in question, then you need to change that to 350 M and memory equal to 750 MI. For the init container also you need to change the same thing, 50. Sorry, first we have to scale it down. Okay, then we have to change it. So K scale deployment memory cloud memory gap down replicas to 0. Then you have to edit. You have to make changes. This changes 350 request and all things, and then wqf, and then get deployment. So it's a 0. Now scale once again to 4. So get deployment app, get demo, get pods. So all is running. So first you have to make it 0, otherwise it won't work, because it is already, it's a rollout strategy. So you have to first make it 0, and then you have to increase replicas. But how do you know this is the 2 container or not? I means how many container is not? So we have taken backup also. So cat bc and then grep, and then you have to image. So you will find 2 images are there. 2 images means 2 containers. Okay, you can take -a5. So -e4. So you will find container this and this. There are 2 container. So you need to divide it by 2. If there is 1 container, no worries. If there is, here is 2 container, but you want to check whether it is the init or not. So instead of E5, A10. So here you will find init container and this second container. First is init container. Sorry, it's a container, then init container. Okay. Or you can only use grep container -i. So here you find container and init container. But in sidecar container, you won't get the information about these two. So both you can execute. First you can execute with the image containers, and then you can execute with the image. So you are damn sure that two containers are present. So you need to, for init there is no worry, but for another container you need to divide it by 2. So control L and k describe deployment my memory demo. So here you will find this two container is running and with the required memory and required things. And if you will describe node 01, so here you'll find that this limit is exceeded, because here message is also there that this could be overcommitted, but this should not go beyond 100%. This become a little longer video, but we'll do more video like this. Part 3 will